Hello everyone, what I want to do is go over quiz 6. The grades were pretty good. Quite a few people, probably most people made little errors on the quiz, so I definitely want to go over precisely how to do each of these problems. So for the first one, we're finding the present value of an annuity due in perpetuity, pays 100 at the beginning of each year for 15 years, and then it increases 5% each year starting at the beginning of the 16th year. So I would definitely draw a time diagram for a problem like this. Okay, so first of all, let's think about what it means at the beginning of the 16th year. It starts increasing by 5%. That is t equals 15. Think about it. T equals 0 is the beginning of the first year. T equals 1 right here is the beginning of the second year, etc., etc. T equals 15 is the beginning of the 16th year. So we have 100, 100, etc., etc., 100. And then we have 100 times 1.05, 100, 1.05 squared, etc., etc. Okay. So actually, I'm going to get my calculator out. Okay, so let's break this up into two annuities. And there's two different ways you can do this. I will do this both ways. Okay, so first, let's, just give me a moment. I'm going to get my calculator out. Always have to do this each time. It's quite a pain. But anyway. Okay, so let's break this up into two annuities. I'm going to do it the following way. This is at least how I would do it. You don't have to do it this way. I would have the last payment to be at the beginning of the 14th year. Okay, so then if I do that, sorry about that, try to get my calculator up. There we go. Put this away for the moment. Okay, right, so if I do it this way, the present value here is 100, a double dot 14. This is a 14-year annuity due. Interest is 7%. All right, so let's just see what we get for this here. Some calculator review. So clear TVM. I don't have a BGN mode, so let's go BGN second, BGN second set. So get out of that. So 100, and I'll make it negative. You don't have to, of course. I like a positive answer. 14 N 7 interest, compute present value. You get 935.77. Okay, and now for the next annuity, it's going to, the first payment is going to be at t equals 14. Right? So I think this lines up to be t equals 14. So it's 100, 100, 1.05, 100, 1.05 squared. Okay, so let's get the present value here. And the formula is just you take your starting value, 100. That 100 increases 5%, so it's minus 0.05 each. Sorry. So I made the mistake that a lot of people did. The formula we have here I'm going to use is for an annuity immediate. It's for an annuity immediate in perpetuity. So I want the present value at t equals 13. You could use the annuity due formula for an annuity in perpetuity, but I think this formula is a little simpler. So the formula is 100 over, subtract off whatever in the bottom. So you first put your interest rate here, 0.07, and then you subtract off by the percentage that the value is increasing each year. It's 5% each year. It's starting off at 100, so 100 goes here. Okay. So this is going to be 5,000. Right, so t equals 0. This is going to be discount it by 13 years. So minus 13, this is going to be, just dump this into your calculator, 5,000 times 1.07 to the 13 minus 2074.82 cents. So I'll just do it also if you want to do it here. Check that we get the same answer. So if you do want to do it at t equals 14, that's fine. The formula here would be 100 times 1.07 over 0.07 minus 0.05. And so here, this is going to be 5,000 times 1.07, 5350. Now, if I do it here, it's 14 years. You discount this by, but you're going to get the same answer. So it doesn't really matter. So let's just check. So this times 1.07 to the 14, exact same answer. So either way, it's fine. All right, just add the two up. It's 935.77, 207.482, and you get 3, 10, and 59 cents. Okay. So, right, alternatively, let's do it a different way, and let's check that we get the same answer. So alternatively, you could include the last 100 payment. That's absolutely fine. So here would be so here technically the payment periods would end at t equals 15. And so this would be 100, that 100A double dots 15.07. Right, so let's see what that is. Clear TVM, quit. So again, it's 15 because this is a 15-year annuity due. So 100, whoops, that is over here. 100 negative payment, 15 N, 7 interest. Compute the present value. So this is going to be 9.74 and 55 cents. Okay. Okay, so now it's basically the same thing. We get rid of this here and get rid of this one here. Well, I guess I shouldn't get rid of the 14. Well, I guess I can. Sure. All right, so let's get rid of this here. So like before, you can do this annuity in perpetuity, either as an annuity due or an annuity immediate. Let me do it as an annuity due, I guess. Right. Just give me a moment here. Sorry about this. It's always a pain to erase stuff. Okay, anyway. All right, so, so the formula is, so here we're really thinking of this as just 105, and each year it increases by 5%, so this is 105, 105, 1.05, et cetera, et cetera. 17 would be 105 times 1.05 squared. So it's 105 times, 1.07, the growth factor, over 0.07 minus 0.05. Now I have to discount this by 15 years. Let's just get what this is. 105 times 1.07 over 0.02 is going to be 5617.5. So the point with the timeline is you're really being careful with how, it allows you to be very careful with how how much you discount things. And again, on my exam, it's, precision is not that important. If you make little boo-boos, I'll just take off a point or two. But on exam FM, being careful can mean the difference between pass and fail. So especially on problems that you do basically correctly, but you make little silly errors on. So 5617.5 times 1.07 to the minus 15 is going to give me, let's see what it gives me. $20.36 and 4 cents. Okay. Right. And so you add these two up. Let me get rid of this here. Yeah, you get the same answer, 974.55. Plus 20.36 and 4 cents gives you exactly same answer, 310 and 59 cents. Right. So either way is fine. Doesn't really matter which way you do. But just, draw a timeline to be careful about how much you discount things. It really does not add too much time to draw a timeline. So, and again, just tips to get the problems you really should be able to get correct on exam FM. Whoops, sorry. Did I erase that for 97.55? 974.55. Okay, so for the second problem, 10,000 is deposited into an account earning 3% effective annual interest. At the end of each year, the interest earned and $500 additionally is withdrawn from this account and put into a second account, earning 6% interest. Find the accumulated value in the second account after 20 years and fill out the following table. Okay, so let's fill out this row here. You start off with 10,000, and each year, at the end of each year, you withdraw interest plus 500. So you have 9,500 at the end of the first year, 9,000 at the end of the second year, 8,500 at the end of the third year, so on and so forth, 500 at the end of the 19th year, and finally 0 at the end of the 20th year. Okay, so the amount deposited into the second account at the beginning is nothing. We're specifying you're not putting anything into the second account. So I should say, like in lecture and in the homework, sorry, it's 8,500, so get rid of one of the zeros. So like the homework and in lecture, I want the actual amount deposited into the second account at each given year. So at the end of the first year, how much is deposited? At the end of the second year, how much is deposited, et cetera, et cetera. Okay, so for this one here, you deposit interest into the second account. So it's 10,000.03 plus 500. Okay, so that's going to be equal to 500 plus 300. Okay, so here you take the year's amount, take interest from that year's amount. So it's 9,500 times 0.03 plus 500. That's going to be 500 plus 285, et cetera, et cetera. So here it's going to be 9,000.03 plus 500 is 500 plus 270. Keep going. This is going to be the previous year's interest is 1,000.03, which is just 30. And last but not least, 500.03 plus 500 is 500 plus 15. Okay, so remember from homework and the lecture that when you have something like this here, where it starts off, where the last payment is 15 and it kind of goes backwards like this, 15, 30, 45, et cetera, et cetera. Basically, this is going to be my P here. Okay, so this is P, 2P, et cetera, et cetera. This is 18 times P, 19P, and last but not least, 20P. Right, so we have a situation like this. So first of all, the 500s, well, that's just a standard annuity immediate, so it's 500, a 20.07. Sorry, we want the accumulated value, so I don't want A, I want S. Well, P is my 15, so it's 15. And sorry, it's 0.06 is the interest for the second account. So it's not 7, 6. So remember, like homework and the lecture, all I need the 3% for is to figure out how much is deposited into the second account each year. Okay? It doesn't play a role in my annuity formulas directly. Okay, so this is my decreasing annuity formula. So P here is 15. So it's P times DS 20.06. And so this is going to be, this is going to be 18,392.7, let's say round up 0.8. And this here is going to be 6,839.2, let's say 2.8. And so this becomes 25,232 and 8 cents. So if anyone might benefit from this formula here, it's 15 times 21.06 to the 20 minus S 20.06 all over 0.06. Let me make that a little neater. So I want to mention some people literally added up, basically added up with interest all these numbers here, which is technically correct. But if I made this something like monthly instead of yearly, and let's say there was 20 years, so that would be 240 months. I don't think you want to add up 240 numbers. So you really do need to use formulas. And I will probably have something like that on the exam where it's a lot more than 20. But if you really do, I guess, want to show me 200, 300, whatever, how many 100 different numbers added up, I guess, I mean, it's definitely, if you're an actuary major, you're not going to pass exam FM with that kind of thinking. You just frankly have no chance of passing it with that kind of thinking. So I think I've mentioned this, beyond just telling you, beyond giving you formulas and working out problems, I'm really trying to drive in to everyone's brains an actuary, an exam FM rather, kind of way of thinking, which is crucial to pass the exam. So yeah. Anyway, all right. Good luck on the exam. Yeah, it's we're in the last third, almost in the last third of the course. Pretty amazing that's gone this fast, but anyway. All right, so long, take care, bye-bye.